Okay, so on worksheet 5, question 3, the two given pieces of information we have are that we're mixing 0.01 molar lead nitrate and 0.01 molar sodium chloride. Okay, so we're interested in whether or not a precipitate of lead chloride is going to form. Now, since lead chloride is going to be the substance that I'm interested in, I need to know what does the math look like for the KSP for lead chloride. So the KSP expression for lead chloride comes from its equation. So PbCl2 breaks down to give me lead, which is a +2 ion, and chloride, which is a -1 ion. And because there's two chlorines here, we have to put a 2 to make two chlorines there. So we have our balanced equation. My KSP expression would look like this. It would look like the concentration of the lead +2 ion times the concentration of the chloride -1 ion squared. Now, if my lead came from the lead chloride, or if my chloride came from the lead chloride, then those would be the numbers, the values of X I could put in there. But I didn't have any lead chloride. I had two different salts. All of my lead came from the lead nitrate. So lead nitrate, PbNO32, broke down to give me my lead +2 ion and 2 of my nitrate ions. Now, because it has nitrate in it, my solubility rules tell me any compound that contains nitrate is super soluble. That's why I drew a one-way arrow. All of it breaks down. So if this is 0.01, then this value is 0.01, and this value is twice as much, 0.02. Now, I don't care about the nitrate. It has nothing to do with my equation in red here. All of my lead came from the lead nitrate, however. So the value that I'm going to put inside the brackets for the lead here came entirely from lead nitrate. It's going to be 0.01. Where did the chlorine come from then? If I didn't have any lead chloride, where did the chlorine come from? Well, the chlorine came from sodium chloride. Sodium chloride is also a very soluble salt. So again, one-way arrow breaks down to give me sodium +1 ions and chloride -1 ions. Okay? If this is 0.01 and all of the sodium chloride breaks down completely in a 1:1:1 ratio, this is 0.01 and this is 0.01. I don't really care about the sodium. It has nothing to do with my equation in red. I do care about the chlorine. All of the chlorine came from sodium chloride. Now, kids quite often say, do I have to times it by 2? No. There's twice as much chlorine as lead if lead chloride is breaking down, but that's not where chlorine came from. The concentration of chlorine came entirely from sodium chloride. We figured it out here in purple as being 0.01. We still have to square it, though, because our math expression for lead chloride says to square it. Now, I can't properly call this a KSP because I'm trying these numbers out. I don't know if I'm at equilibrium or not. That's what we're testing it. So because I'm trying it out, instead of calling this a KSP, I'm going to change the name to the QSP, where Q means quotient. It means that we've multiplied things. So it's a trial KSP. We're trying this out to see what these values will give us. So what we're going to do is we're going to first square chlorine, so 0.01 squared, multiply that by 0.01 again, and that gives us our value for QSP. So the value we get when we factor that out is 1 times 10 to the -6. Now, in order for us to determine if a precipitate forms, we're going to have to go and find out what the KSP is for lead chloride. What would be the actual equilibrium value? And since they didn't give it to us in this question, we're going to have to go look it up on a chart, which is on page 969 of your textbook. Again, so on page 969 in our text, we see that the actual KSP for lead chloride is 1.7 times 10 to the -5. But our trial value is 1.0 times 10 to the -6. Obviously, the values we put in may result in a lesser amount. So in this case, when we're comparing our KSP and our QSP, the KSP is a bigger value. And if the equilibrium value is bigger than what we have, there's more room to dissolve things, so there is no precipitate. If the KSP value was smaller than what we had, if the KSP was less than the QSP, well, that would imply there was more ions in the solution than the solution could actually hold on to, and a precipitate would have to form.